Hello, guys. Welcome to my channel. Uh, Let me introduce myself first. So, my name is Arnav Goel and I am from Triple IT Soripat, doing BTech in CSE in third year. You may say, like, no, where is your consistency? Or, like you said, you will be consistent. I let you tell you what is happening so far. I am trying to make a video since past 2 days uh, for a particular problem. And I have just, I think I decoded 45, at least 45 times. So many issues comes. Uh, Maybe light goes. Someone called me. Software doesn't work properly. I just by default use stop recording. I don't know why. And if I just forgot to connect with my earphones, and this has happened just like before, just today. Uh, I just forgot to connect with my earphones. Oh, I don't know how to explain what is going on. Just making a video is itself getting so much hard for me. So yeah, without any much further delays, let's start with the problem. I think this time, please, everything just goes fine. Uh, and today, I will post 3 videos. Uh, so yeah, start with the problem. The question is from codeforces. The name of the problem is the party and the sweets. So I would recommend you to read it with yourself because I know that the problem statement is quite tricky, but try to read it by yourself or just read it thoroughly and thoroughly. And if you don't get it, just put the statement in ChatGPT. If you didn't get it there too, I will also explain in the whiteboard. You can see there. So let's move to the problem statement to the then whiteboard. So yeah, I never do like this way. Always read the problem statement too and then start the things. But how can I tell you like 45 videos I have made and just doing the same thing and same thing and same thing. So I would think like this one is also a good way to like without any much wastage of your time, just start with what I've done. So we have N, we have M, we have N and M, where N represent, where N represent number of boys and M represent number of girls. Where what is happening so far in the program? So there is some festival. In that festival, each and every boy just go to the girls and give them some sweets. What does this mean? So let us suppose there is a boy and he goes to girl one, girl two, up to girl M. Uh, He gives girl one zero sweets, girl two three sweets, and so on. So this is what is happening so far. And the problem statement is giving that array B and array G. That is B1 to Bn and G1 to Gn. So what does B array means and G array means? So first of all, what does B array means? B array means that a particular boy just giving distributing minimum amount of sweets to some girls among all of the girls he distributed. What does this line mean? Let us suppose we consider boy one. He goes to girl one. Then he goes to girl two and he goes to girl three. He gives three sweets to girl one, five sweets to girl two, and one sweet to girl three. The minimum number of sweets that he could give, that he gives to a girl, to some girl, among all of the girls. There are a total 3 girls, and the minimum number of sweets he gives that is one to only to girl three. So minimum is one. So B1 is one. Then we will think about like what about let's move to the boy two. So he gives girl one three sweets, girl three, girl two zero sweets, and girl three zero sweets. The minimum he gives to some girls. So there are 3 girls, and among all of those 3 girls, he gives zero sweets to all 3 girls. That is the minimum sweet that he can give is zero. So the B2 will be zero. That is the minimum. So this is what B array means. What about G array then? So G array means let what does this mean? Like a particular girl getting maximum amount of sweet from some boys among all of the boys who distributed sweets to that particular girl. What does this line mean? Let us suppose there is girl one. she got sweets from boy one, boy two, and boy three. Since there are three boys total. So from boy one, she got five sweets. From boy two, she got six sweets. And from boy three, she got three sweets. The maximum she got is from boy two, that is six. So G1 will be six. Then we move to girl two. She got from boy one one sweet, from boy two one sweet, boy three that is one sweet. So the maximum that she got among all of three boys, uh, that is boy one, boy two, boy three, that is one. That is G2 will be one. So this is what B array means and what G array means. And you may see you may see something. Wait a second. You may see something array A2 like A of I of j. You may see that too. What does this A of I of j means? So you have an array A that is actual array. What does this mean? That is actual array. This is actual array so far. Uh, that the boy gives actual sweet to a girl. The boy gives actual sweets to a girl. This is what array A means. So what does like let's suppose there is boy one, there is boy two, and there is boy three, and this is girl one, girl two. Okay, so boy one gives girl one three sweets, girl two five sweets, boy two gives six sweets, and so on. This is what actual representation. This is what actual a boy gives to a girl a sweet. This is what array A means. Those B and G array are like minimum and maximum. But that array A is totally like real, actual. So like if it is actual, then how can we find out array B and G from this array A? Okay, nice question. So wait a second. So like consider this thing. Okay, this, and this, and find out the minimum. 3, 1, and 3. So this is your array B. Why array B? Since boy 1 gives girl 1 3 and girl 2 5. So minimum so far, that is 3. So B1 is 3. B2 is 1. And so on. This is what B array we can get from array A. Now what about G array means? From array A, how can we find out? So girl 1 get 3 sweets from boy 1, girl 2 gets 6, and oh sorry, girl 1 gets from boy 2 6, and from boy 3 7. So maximum so far is 7, and same with this. So the maximum a girl 1 can get is 7 from a particular boy, from some boy. So that is 7, and so on. This is G1 and this is G2. This is what array G means. So what we have to then output, we need to output the total sum of the sweets that the boys gives to the girls. What is this means? That is 3 plus 5 plus 6 plus 1 plus 7 plus 3. That is 8, 14, 15, 20, 25. So 25 will be. But we need not need to like total sum. We need to minimize this. This is actually the representation. But after following the conditions of B and G array, what we got is that is wait a second. What we got is this 1 1 1 1 2 3. So the total sum is 9. We got it. So this is our answer. So like if you like n and m ranges to 10 to the power 5. So if you try to manually put down the elements in array A, this will be cost on 10 to the power 10, that is n into n. And we know that to be in the safer limit, not get TLE, the minimum that we can maximum that we oppose to up to 10 to the power 8. And so we have to be in order of n plus m, order of n logarithmic of m, something like that. With that, we cannot go with order of n into m. So how we will find out? So first of all, I already said the question part is tricky, leading statement is tricky, but everything code and intuition is totally easy. I have coded the intuition so far. Like when I code into a very complex way. I don't know why I did I so, but when I see the editorial and some other people's code, users code, I think like the same intuition I have also used, but I have done into a complex way. I don't know why I did so. So yeah. So first of all, let us suppose where there's some. Let's take some input case where we were. It is, yeah, it's recording. So, like, This is B array that is 1 to 1, and this is G array that is 3 and then 4. So don't think anything, just try to sort things up. I don't know why I'm sorting. The reason, like, don't have a particular reason, but sorting it because I just wanted to see a clear vision. Wait a second. Uh, I just want to get a clear vision so far. That's why I am sorting. I don't know, like, sorting will help or not, but just a clear vision I want. So for clear vision, I did so. This is array B, this is array G. So how we will do then? So first of all, we need to construct array A, but not everything we will put manually. This is boy 1, this is boy 2, this is boy 3. This is girl 1, this is girl 2. So we like first of all, how can you get the total minimum sum? You will get the total minimum sum when every and each element of it is the minimum that we can put so far. What does this B1 means? Like this one. For boy 1, what does this B1 means? That the minimum he can give sweets to some girls. That is one. It may be possible that he gives one sweet to all of the girls, but he needs to give at least one sweet to a particular girl or some of the girls. So we know that the minimum that we can give, that boy one gives, is one sweet, not lesser than that. Not lesser than that. We cannot minimize this. Maybe maximum that, but not lesser than that. So we need to find out the minimum. So what we will do, since we know that we don't know right now, but it can be possible that girl 2 and girl 1 both can give the same one sweet. So we will put the minimum so far since we need to find out the minimum total sum. That's why. And also it may be possible that all of them get the minimum out of all. So this is why we are doing so. So this is half part. Since part we have constructed and this 3 and 4 is just like now this thing left, like this condition. So we need to think about that. Now, first of all, without like when will the answer will not exist? That is minus one when will happens. So let us suppose the same situation. That is 2, 3, and then 4, and it's 1, 5, and 7. Oh wait. Yeah, this is G. So when will be the answer not exist? That is minus one when we will put. What does this means? That is the minimum of L. That is the minimum. That is after sorting we get is 1. What does this mean? That one means that a girl get a maximum amount of sweet from a particular boy. A particular maybe some of the boys that is suppose that from a particular boy she get, let's suppose it's boy 2 or maybe boy 3, you can think of that. That is maximum she can get 1. And what does this mean? That is B1, that is 2. That is minimum he could give to a particular girl or some girls. To some girls. That is 2. Isn't you feel that this and this is contradiction? Isn't it you feel? Yeah, this is contradiction that one is saying I get the maximum from boys 1 and some is saying like minimum that I can give 2. So it's totally contradiction. So minus 1 will exist when this that is maximum of this that is 4 is uh, greater than this one. That is 1. Wait, that is this. We need to just check for this because like if this one is alone greater than wait is lesser than this one, then everything will be fine. Like 2, 3, 4, and maybe like 3 and then 5. Then this situation is correct. But what about this situation? This situation. So we need to just check for the maximum of array B, the last element of array B, and the last first element of that array G. Just only we need to check. Like it should be lesser. That is array n minus 1 b b of n minus 1 should be lesser than or equal to g of m minus 1. We need to just check this thing. Okay, so we check. Okay, we first of all check that. Now we have just put that array elements in that. Now we need to construct that how the condition for g. how can we construct? Since we know that the minimum we need to find out. So will you try to change this or this? Since we know that we need to put the maximum element, that is 3 and 4 also has to be put because some of the boys have also give 3 maximum sweets and 4 maximum sweets. You know that? Yeah, you know that. So 3 and 4 has to be present at all. And where you can fit 3 and 4, think, should I put at the minimum side or at the maximum side? Like if we try to put that at here, so minimum would decrease, minimum amount would decrease, so it will not lead us to the minimum. And if we try to put this, even though that things will no not that much change, but what I was saying that at boy one, that is the minimum that we put, that things will like not will get the optimal value. You can get, I know you will know like why I am doing so. So at only boy three, we will put like boy three is the only one who puts the maximum sweet so far, who gives the maximum sweet to that girl, to girls. That is, we will put 3 and 4 at here rather than 2 and 2. You may think what you are doing, what I am saying. I know that this one, what I am done is wrong. I know that. What I'm saying, like so far we have done like wait, 1, 1, 2, 2, and we have 3 and then 4. We know that we need to optimal minimum. We need to put minimum. So why not just put that maximum at boy 3 or at boy 2? Like M girls here, the boy 3 gives sweets at M we have. So why not we put at boy 3? Since we cannot put like the maximum at here or maybe at here, this will decrease like this will decrease the frequency of the minimal and elements. So we will put at boy 3. That's why. So I put 3 and 4. The maximum, that is 4 and then 3. But we also like this is the situation. But you may say like where does 2 goes? Where does 2 goes from here? Like uh what I'm saying at 1, 1, 1, 2, 2. It would be look like 1, 1, 1, 1, 3, 4. You may say. You say that okay, fine. This situation works. This situation works, but why not? Like this situation doesn't work. But like wait, what I'm saying, 1, 1, 2, wait, 1, 1, 3, and then 4. For G respective, this works. For G1 and G2, this works. Okay. And for B1, this works. For B2, this works. But when it comes to B3, this doesn't work at all. Minimum is 3. And you but it should be 2. You may say, yeah, that's correct. So what we will do, if this is 2 and 4, let us suppose is that array G is 2 and 4, and what the elements are 1, 1, and 2. What we will do, just put at that take the same thing, that is 1, 1, and then 2, 2. What we will do is just change this thing only, like this, that is 2 and 4. Since now that array B means and array G, all condition follows, and the minimum element, that is 2. But at here, what we will do is to put 2 at here because we need to follow the condition at, and since only one girl left, that is 3. We will put at here. What we will do, it is put at here. That is at girl 1. Okay. You may just can put at anywhere, but just you may follow the conditions that I will put at here at this point. So girl G array follows conditions and B now follows. So like when we will move to the previous boy, when like this is 2 and this is like if uh, B of n minus 1 is equal to G of 0, if this is happens, so just only at boy n minus 1 you will just change all of the things like that I have done right here. It has 2 and 4 I have just put up, and everything just remains same. But when they are not equal at all, then this will work. Like you will just put 2 and that rest of the things will remain same. And then that 3 you will put at G1, that is at here. This is what array A then will look like, and this will be the optimal so far. I will take another test case. Maybe it will help you a lot more. Since I just see is the video is recording or not. I just want, yeah, it's good. Ah, so again, we will sort this up. And now already I told you why we are sorting now for the clear vision and also the reason like the last element and the first element. So can you see like zero, like one is greater than zero, but we need to find out like, but this is not the condition that is to be. So we will put minus one. Then see this. We will first sort one and two. So array A we will construct. So boy one, wait. Boy one, boy two, boy three. Girl one, girl two, girl three. Wait, I forget that there's two boys only. Forget it. Okay, so minimum first of all we will put, and the situation of minus one will not be considered since everything is cosine. So boy one just put 0 0 first of all we will put, and same for that boy two. Now we know that this and this is same. So like what we need to do is just change this part only. It is one and let it be like that. So we will find out the total sum is four. So this is what we need to do. I think you got it why we are doing, and this is the optimal that we can get so far. And you may think like Arnav, you are again doing like you are just putting elements and order into order of any term. Not at so. Since what we will do is like sorting, we just do zero and one. That is zero into m plus one into m is the total sum total that we can find that we will do. That is 0 0 that what we have done so far, that is 0 0 and 1 1 initially. So the same thing that we will do. Now the thing changes for like is that the last element of array B and the first element of array G equal or not? If they equal, then what we will do is uh, find out the total sum of this, that is 1 1 1 2, 1 plus 1 plus 2, and remove the remaining part. That is like that this is 1 1 1 and this is 1 1 2. So where we need to change that is total sum is 5, 2 plus 3 plus 4, 4 minus like the calculation rate, 4 minus 3 that is 1. So additionally plus 1 will be we will do to our current sum. So current sum was 3 plus 1 we will do that is 4. So 4 will be the answer. What if they are not equal? What if they are not equal at all? Then let us suppose it's 2, then 0 0 0 1 1 1 and 1 1 2, something like that. What we will do, first of all, the same thing. This one will be remain same, and the rest one will be without taking care of this. Add these parts, the rest of the parts that is from m minus one. You will do, and then remove from here. That is the boy. Then you will switch to boy n minus two, and remove this one like the overall difference, then you will add like that the way that we have done for that the previous situation. I will explain it in the code. I am not using my code. I am using Ericto's code. He is a good coder. Wait, I just moved to there because I have done into a complex way. That's the thing. Wait a second. Friends and Ericto. Yeah. So what he did he done? So in 10 and m, he just take that values and then for the vectors, the same thing that is he will take array A and array B, that is B and G. And again he sort it up. And if the same condition, if the last element of array A is greater than the first element of array B, we will print minus one. Then we will take long answer equal to 0. And the same thing that I was doing, that is x into m, that is 0 into m, 1 into m that we have done. So the same thing, answer we have done. And then for int x b, like that array g, we will just do what? That every element just a dot back. That is a dot back, that is the last element. What does this mean? Wait. A dot back here means, wait, where? So 0 and 1 was this is a dot back. So we will minus 1 that we will do and the add and each and every element of that of array G we will decrease minus 1 and add with our sum. So far that what I have done like one that this thing you can see this thing that is 112 that is 4 minus 3 I was doing like each and every element of that is subtracting from the last element of that array A total of array B. The same it is doing then the same situation uh, if they are not equal that means they that is greater than that. So what we will do a dot back minus a dot end of minus 2 that is remove that element and then just put the total thing overall. uh, and then we will just output. Wait, I think you may not get that greater one. So let us suppose this is 0 and then 1 and 2, 2 and then 3. So 0, 0, 0, 1, 1, 1. We just try to put up the things and it would be look alike 1, 2, 3. So what we will do, we have just solved this part and this 2 left. So what we will do is to put it here. So 2 minus 0. The total sum we will do answer plus equal to 2 minus 0 that we will do. That is the boy minus 2 n minus 2 we will do for that. So this is the overall thing, the overall question. I know that the statement part is quite tricky, but I think you may get the proper explanation of how this code, how this problem is too much easy. Just a little bit intuition that you will need. So like if you have any doubts, just put that in the comments and I will reply to that. And that's from my side. So bye. See you soon. I think wait a second.